Hello and welcome to my video. If you have read the title of this video, no, I do not think that the 2D geometry is boring at all. There are actually some quite fascinating and difficult and complicated problems and properties in 2D geometry as well. But here in this video, I am going to present you one of the simplest problems that is happening in 3D space. So let's get on to it. I'm going to read the problem first. Point A lies on the intersection line between two planes that are vertical to each other. Draw two lines AB and AC on each plane that are 45 degrees angle to the intersection line. So under this condition, find the angle BAC. Okay, first we have to visualize this problem. So let's get on to that. Now here are two planes that are vertical to each other, and we have an intersection line here, and we have point A on the intersection line, and we have line AB on this plane and line AC on this plane. So first, let D be the foot of perpendicular from point B to the intersection line, and similarly, let E be the foot of perpendicular from C to the intersection line. Now, these point B and point C are only mentioned in the problem to indicate the angle BAC. So we are going to just let length AB equals A and AC equals A just for calculation, which means that we simply take point B and point C as points that are distance A apart from the point A on the intersection line. And now we have to consider the 45 degrees angle condition. And for the possible arrangement of these points, there are actually two different cases. So the first case is where point D and point E coincides. So we have 45 angle to this direction and 45 degrees angle to this direction. And the second case is point D and point E are not the same point. So we have angle 45 degrees to this direction and 45 degrees to this direction. So let us consider each case. All right, so let us consider the first case where point D and E coincide. Here we know that this length BD equals A over square root of 2, and CE is also A over square root of 2. Therefore, using the Pythagorean theorem, we can calculate the length BC, which is simply A. So this length right here is A. Therefore, triangle ABC is an equilateral triangle. Therefore, this angle BAC is simply 60 degrees. Okay, so this was the first case. And now let's move on to the second case. Okay, the second case is where points D and E do not coincide. First, notice that this length AD is A over square root of 2, and this length AE is also A over square root of 2. Now notice that this line BD is perpendicular to this plane. This means that BD is perpendicular to any lines on that plane. So we have BD is perpendicular to line CD. So we have another right angle here. Therefore, by the Pythagorean theorem, we have BC square equals BD square plus CD square. And for this CD square, we can apply the Pythagorean theorem again for triangle CDE. So we have CE square plus DE square. And since this length BD is A over square root of 2, we have A over square root of 2 square. And since we have A over square root of 2 here, we have A over square root of 2 square here. And length DE is simply A over square root of 2 plus A over square root of 2, which is simply square root of 2A. So we have 3A square here. So we have length BC of square root of 3A. So this length right here is square root of 3A. Okay, now we have to calculate this angle, and here angle BAC can be obtained by two methods. The first method is using the law of cosine on triangle ABC, which gives cosine of angle BAC as AB square plus AC square minus BC square over 2 times AB times AC, which is A square plus A square minus 3A square over 2 times A, which is simply minus 1 over 2. which gives angle BAC of 120 degrees. Or for the second method, we divide the triangle ABC into two smaller triangles. So let F be the foot of perpendicular from point A onto BC. Then since length of BC is square root of 3A, the length of BF and CF are both square root of 3 over 2A. And by the Pythagorean theorem, you can easily obtain this length is A over 2. So if you look at the ratio of side length, you will notice the 1 to square root of 3 to 2 ratio, which means that this triangle here is a 90 degree, 30 degrees, 60 degrees triangle. So we also have 30 degrees and we also have 60 degrees here, which means that the angle BAC is equal to 120 degrees. So these are all the possible values for the angle BAC. And that was all for today's video. Thank you for watching, and I will see you in another video.